Okay, part 2 of units of concentration will focus on molality. The equation for molality is moles of solute is divided by the kilograms of solvent. So M is going to stand for the molality, and it's important to understand that it's often referred to as the molal concentration. What we'll have to be cautious about is the fact that we have the solute being divided by the solvent, and so each problem will have to identify the solute and the solvent, because if you were given both of them in grams, you can change grams to moles and you can change grams to kilograms. So we're going to have to discern them. Alright, so here's our first problem. What is the molality? And we have 3.0 moles of sodium chloride and 1.5 kilograms of water. So we're going to place our molality equals moles of solute divided by kilograms of solvent. And what we need to determine is what is sodium chloride and what is water. Water is considered a universal solvent, and so when we see this, we're going to go ahead and automatically label water as a solvent, even though there's very, very, very rare cases where it would be otherwise. Water is pretty much always going to be our solvent, which makes salt our solute. So solute is going to get changed to moles, and our solvent is going to get changed to kilograms. Now I'm going to place my givens, 3.0 moles of sodium chloride over my solvent, 1.5 kilograms of water. Since I already have my solute in moles and my solvent in kilograms, then I can go ahead and solve this. 3.0 divided by 1.5 is going to equal 2 moles over kilograms, which is 2 molal, and that'll be what the concentration of my solution is. Okay, another example where they ask what is the molality. This time we're given 25 grams of sodium chloride and 2 kilograms of water. So molality is going to equal moles of solute divided by kilograms of solvent. This is our solute because water is our solvent. Again, solvent should always be in kilograms, and our solute is going to have to be in moles. So I'll take my givens, put the solute, 25 grams of sodium chloride, over the solvent, which is 2.0 kilograms of water. Now I do not have to change my solvent because it's already in kilograms, but I do have to change my sodium chloride. So we're going to bring down grams of sodium chloride. We're going to go from grams to 1 mole by going to the periodic table. Sodium chloride is 58.44 grams. Grams cancel, and notice now I have moles over kilograms. So I'm going to calculate 25 divided by 2.0 divided by 58.44 is going to give me 0.21, and that's molal. Okay, in this case scenario, it's going to be a little bit different. How many grams of iodine should be added to 750 grams of carbon tetrachloride of a 0.020 molal solution? So first of all, we need to identify our solute, which is going to be iodine, and our solvent, which is going to be carbon tetrachloride. One of the rules of thumb is that your solute is added to your solvent. Otherwise, carbon tetrachloride is a common solvent, and iodine is a solid typically used as a solute. So we also need to convert our molality. And so to do this, we're going to rewrite 0.020 molal as 0.020 moles over 1 kilogram. So we're going to change our molality to this because they are equal. Now I'm going to put my givens. My given 750 grams of carbon tetrachloride over 1. I'm going to bring down grams of carbon tetrachloride, and because this is my solvent, I want it to be in kilograms. So I'm going from gram to kilogram. 1 kilogram equals 1,000 grams. My grams cancel. now I'm at kilograms of carbon tetrachloride, times draw a line, bring down kilograms, and this is the moment where I'm going to use this conversion factor where 1 kilogram is equal to 0.020 moles. So your goal is to get to kilogram or moles so that you can use the molality in your problem. So now kilograms cancel and I'm left with the moles. Now we'll bring down moles. 1 mole of iodine is going to be equal to 253.8 grams of iodine. So to get your final answer, we're going to take 750 divided by 1,000 times 0.020 times 253.8, and that gets us 3.8 grams of iodine. In this problem, they're asking how much water should be added to 5.00 grams of potassium chloride in a 0.5 molar solution. So water is our solvent, and they said how much, they didn't specify, so we'll just end our problem at kilograms. And they gave us the amount of solute, which remember should be in moles, but they gave it to us in grams. We're also going to take our molality and convert it. So it's going to become 0.500 moles over 1 kilogram. So we'll start by taking our given 5.00 grams potassium chloride, put it over 1, bring down grams of potassium chloride, and we're going to go to a mole. 74.55 grams of potassium chloride equals 1 mole. So now grams cancel and I'm at moles. We're going to bring down moles of potassium chloride, and here's where I'm going to be able to use my molality. 0.500 is going to go at the bottom, and that's going to equal 1 kilogram, and that's of water. So now my moles have canceled and I'm at kilograms of water. So we can get our final answer. 5 divided by 74.55 divided by 0.5 is going to equal 0.134, and that's kilograms of water. That's the same thing as 134 grams of